Alrighty, 8.4, proportionality theorems. Proportionality theorems. So the first one is the triangle proportionality theorem. It says, if a line parallel to one side of a triangle, here's this side is parallel to that side of a triangle. If this line is parallel to one side of a triangle, if it intersects the other two sides, then it divides the two sides proportionality. So here's a giant triangle right there. And if these two lines are parallel, that means the sides are proportional. A is to B as C is to D. A is to B as C is to D. Converse of the triangle proportionality theorem would also work. If P is to R as T is to U, if P to R is equal to T over U, if these are proportional, if these are equal, that means these two lines will be parallel. This is the converse of the proportionality theorem. Okay? What if you have something like this? If you have a whole bunch of lines here, come on. What if you have a whole bunch? Here's a triangle with a whole bunch of lines. All these lines are all these lines are parallel. And here's some sides. Maybe they meet, maybe they don't. Okay. If all these lines are parallel, then A is to B as B is to C. Sorry, A is to B as E is to F. A is to B as E is to F. B is to C as F is to G. C is to D as G is to H. All these things are going to be proportionality. A is to B as E is to F. B is to C as F is to G. You can also do this way. As long as these lines are parallel, A is to E. A is to E as B is to F. This is, for me, this one's easier for me to remember this way. As C is to G. As D is to H. Now, that works as long as these lines are parallel. If these lines are not all parallel, then this doesn't work. Okay? And that's the 3 lines parallel theorem. In this case, there's 4 lines. As long as all these lines are parallel, it's going to work. Next one, the triangle angle bisector theorem. Here's a triangle. As long as that's an angle bisector, you can say P is to Q. P is to Q as A is to B. Those will be equal. If you want, you can also set it up as P is to A as Q is to B. That would also work. It's an equal sign. Either one works. PB, QA, PB, QA. Either one of these works. I don't care which way you memorize it. Either one will work. That has to be an angle bisector. If that's not an angle bisector, this is not going to work. I don't care if it looks like this. As long as that's an angle bisector, P over A is going to be equal to Q over B. This distance over that distance is equivalent to that distance over this distance. Okay? There we go. Now let's try and put this into practice using some problems. Number 3. Question number 3 says, find the length of side AB. Find this length right here, So, what's the length letter that's not on it? X is not on there, so I'm going to use X. So, I copied question 3 without all the letters. That's the distance we have to find. Without all the letters, I'm getting rid of the stuff that we don't need. Okay, all I need to know is, as a triangle, these sides are parallel. Well, if that's true, I want this letter on top. X is to 12, as 3 is to 4. Boom. That's the easy part. From here to here, That's the hard part. The rest is easy. Because this is algebra stuff right now. Solve for this. 12, 3, 3, 6, 4. That x is 9. Units. Draw a box around your answer. In this case, x is 9 units. The book, it'd actually be AB. AB. AB, side AB is 9 units. Okay. Question 6. Determine whether this line is parallel to that line. Well, this is just the converse of that one. In this case, these lines are parallel, which means x over 12 equals 3 over 4. In this case, we have to say, hey, if 22.5 over 18, if it equals this over this, 25 over 20, if they're equal, that means these lines are parallel. If these are not equal, that means these two lines are not parallel. So let's see if they are equal or not. 22.5 divided by 18 is 1.25. 25 divided by 20 is 1.25. Yes, they are equal. Therefore, these two lines are parallel. That means KM is parallel to JN. Boom. Come on, get in there. There we go. Okay. Beautiful. Question number 15. We have this. We have this stuff drawn right here. And this question 15 says, use this diagram to complete the proportion. So we have to determine EG. So in this case, EG, this distance from E to G is right here over CE. This over this equals FD over what? That. EG over CE, this over this distance over that distance will be equivalent to this distance over that distance. That's dB. So what has to go right here? dB. You can put BD or you can put dB. Either one, it's going to work. Sweet! What am I? Question 21. Find the value of the variable. Find the value of the variable. Hey, that's an angle bisector. Sweet, we can use that theorem we just had over right here. Use this one. Hey, so I can say 16.5 over P equals 11 over that distance. So this over that equals this distance over that distance. 16.5 over P equals 11 over that distance. It's 29 minus 11. The whole thing is 29, that's 11. 29 minus 11 will give us that distance right there. There we go. Now, we can simplify this. There's no variable there. What's 29 minus 11? Calculator minus 2 really? Is it 40? No, that'd be plus. 16.5 divided by P equals 11 over 18. That's going to be 18 units. So now we need to find the value of P. P is in the denominator. We don't want it in the denominator. So we're going to cross multiplies. P times 11. That's 11, not an H. Equals 16.5 times 18. Okay. P is now in the numerator times 11. So what's the opposite of multiplying by 11? Dividing by 11. Divide both sides by 11. So now those cancel. P is remaining. 16.5 times 18 divided by 11. 16.5 times 18 divided by 11. 27. Boom. For this is question 21. Question 21. P is 27. And we're done. Well, come on. Don't make that mistake. Units. Don't make that mistake. Boom. Done. Ooh, under 11 minutes. This is a quick one. Hasta la bye-bye.